guys, so in this video we're going to talk about how to find out whether a p-series converges or diverges. And the p-series conditions are stated right here. If p is greater than 1, converges. If p is less than or equal to 1, diverges. And the formula we're going to use is right here. As a series of n starting at 1 approaches infinity of 1 divided by n raised to the p. So anytime we see this form, we apply the p-series. And this is the problem that we're going to do right here. So the first step we need to do is we need to isolate it so we have the form of p-series. So step 1 is we use algebra to get it in form of p-series. So that's the first thing we're going to do right here. So notice how right here we have a function. Our 1 over n raised to the p is equal to n within the cube root. So first thing we need to do is we need to simplify this. So knowing this, our n is n raised to the 1. And our cube root, we can rewrite it as n raised to the 1/3. And then by applying the exponential property, since this is division, we can just subtract the exponent. So 1 minus 1/3 is equal to 3 over 3 minus 1/3, which is equal to 2/3. So that's our function. So our function essentially is, let me clear out space to rewrite this. So I'm going to keep the 2/3 because that's what our p is. So simplifying this, we get the series as n starts from 1 and approaches infinity is equal to n raised to 2 over 3. Now we have to have it in the form of 1 over n raised to the p. So to do this, all we simply do is just rewrite this. So 1 over n raised to the negative 2/3. So now we have our p. So that's the next step. So for step 2, all we're simply going to do is we're going to identify p. So this one's pretty straightforward. We did all the arithmetic in step 1, and our p came out to be equal to negative 2/3. And since p is less than 1, because negative 2/3 is less than 1, we apply the p-series conditions, which are right here. And whenever p is less than 1, which it is in this case, our series is going to diverge. So this series is diverging. So I'm going to go ahead and put that as step 3 so that way we can identify with it. Step 3, we are applying the p-series conditions. So in this case, we know p is less than 1. So since p is less than 1, the series as n goes to 1 to infinity of 1 over n raised to the negative 2/3 this series diverges. And that's how you basically find what p series is. So all we did was, in step 1, all we did was just perform algebra in order to solve, to get it in the form of 1 over n divided by p, n raised to the p power. Step 2, we identified p was 2/3. In step 3, we simply just tested the condition, and this particular n diverges. Thank you for watching. I hope that was helpful. Hello, so in this example, we're given e raised to the 3rd power divided by n raised to the 2 pi. And the first thing that we're going to do is we're going to simplify this. But before that, I'm going to leave a note saying that if you are given constants, just ignore them. Why? Because they will not help you solve for p. They will not help you solve p. Basically, it's just like whenever you integrate, you pull the constant out and you multiply it back in at the end. That's the same case here. So in this case, we're treating e raised to the 3rd power as a constant because it's not going to help us. So now that we know that, we can go ahead and proceed with the problem. So our first step is to use algebra to get in form of p series. So in this particular problem, with the understanding that e raised to the 3rd is nothing more than just a constant, we actually already have it in a p series form. So p series form is really 1 divided by n raised to the p, which in this case, our series particularly would just be 1 over n times 2 pi. So now that we know that, the next step, step 2, is we identify p, because p is the variable on our, p is the exponent on our n term. So in this case, our p comes out to be 2 pi. So p is equal to 2 times pi. And now that we know that, we can proceed to step 3. So for step 3, we test the p series conditions. So real quick, I'm going to go ahead and zoom in on the p series conditions so that way you can see them. So these are the p series conditions right here. If p is less than 1 or equal to 1, diverges. If p is greater than 1, it converges. So clearly, as we can see here, 2 pi is clearly greater than 1. It's clearly greater than 1. If you type in 2 pi in your decimal, in your calculator, you'll get a number that's approximately 6.28, whatever. So in this case, since P is greater than 1, we say that this particular series converges. And that's our answer for this particular problem. So in quick retrospect, we're going to simply analyze what we just did here. So first, they ask us to find whether the p-series converges or diverges. So first thing we did was, before we do the algebra to get in the form of p-series, we make a note to ourselves that if we're given constants, we just ignore them because they will not help us solve for p. They will not help us tell whether p converges or diverges. We're only looking at nth terms, and I'm going to go ahead and add that as well. So we're only looking for the terms with n. So make note of that as well. And then from here, we got it in p-series form. We got 1 divided by n raised to the 2 pi. In step 2, we identified p to be 2 pi. And then in step 3, we test the p-series conditions, which are right here. Since our p is greater than 1, and we got 2 pi, this whole series converges by p-series. Thank you for watching. I hope that was helpful.